You're live.
Okay. All right, so we're talking about calibration now in your Xgards. So we've talked about the fact that because of the gases that you have present, we're going to use 50% propane, LEL, pentane, sorry, thank you for correcting me, 50% pentane, and we're going to set your output to be 35% LEL. Just in case you don't know what percent LEL stands for, it's percent of the lower explosive limit. So you can't actually have an ignitable environment until you reach 100% of the lower explosive limit. You can strike a match all day at 99% and it won't explode. But at 100% you can actually have ignition. Okay? Alright, so again we're going to use 50%, but we're going to set our display to read 35%, use that correction factor of times 0.7. So that's going to be our span gas. But before we do a span calibration, we're always going to zero the transmitter. And because we may be concerned about contaminants in your area, we're always going to expose that sensor to a purge gas. Okay? So this is important as well. When you order a zero gas, if you call a manufacturer and you try to buy somebody's gas and you say zero gas, sometimes they'll send you 100% by volume nitrogen. Again, it's recommended that you have air even in your zero cylinder. So you'll see the cylinder that I use is 20.9% by volume oxygen, balanced in nitrogen. Okay? So that's my zero gas that I use. Alright? Okay, so...
What was that percentage? 29.9?
20.9.
20.9.
Which is clean ambient air.
Okay.
Alright, y'all have some of these Xgard manuals left with you. There is 2 test points that you are going to use a voltmeter to read an output signal linear to what's being sent back to your controller system, which is the Vortex. I believe it's TP1 and TP2.
That's correct.
So it's called test points 1 and test points 2. And it's in your manual and actually shows you a diagram of those 2 test points. Okay? So what you do is you take your voltmeter, you put it on DC millivolt range, and you take your probes and you touch test point 1 and test point 2. Okay? It's going to range somewhere between 40 millivolts and 200 millivolts. Because remember, you have a 4 to 20 milliamp signal here. So the millivolt output that you're reading on your voltmeter is 40 millivolts to 200 millivolts. Okay? So when you do your zero, which is what you do first, you're going to apply your calibration gas. When you get the cylinder, you'll screw on a regulator. And the regulator will either need to be a 0.5 liter per minute through a 1.0 liter per minute regulator. That's the flow rate you want to use for calibrating an Xgard. Okay, so you can use anywhere between a 0.5 and a 1.0. Alright? So you'll take your regulator and attach a hose to it. And at the end of that hose, you'll have what we call a calibration adapter. This calibration adapter, I know you can't see this real well, but it slides right into the nose section of the Xgard. So when you open up the cylinder, passes gas through your tubing, through your calibration adapter, and saturates that little compartment where the sensor is. Okay? So when you apply zero gas, and you have your voltmeter connected to TP1 and TP2, you're going to look for an output of 40 millivolts. If you're not reading 40 millivolts, you will see on your Xgard, you'll see 2 potentiometers, one labeled 0 and one labeled, is it calibrator or span? Cal, thank you. Cal. So when you're applying your zero gas, which pot are you going to use? Zero pot, right? So you're going to get in that potentiometer and you're going to turn it clockwise to increase it, counterclockwise to decrease it, and you're going to set it at 40 millivolts. When you set it at 40 millivolts, you want to verify on your control system, your Vortex, that it's reading 0% LEL. Okay? So 40 millivolts represents 0% LEL. So once we've got our zero set, we're then going to take, if you only have one regulator, you'll unscrew your regulator. You'll place it on your, I was confused all the time, pentane. And then you're going to apply your pentane. It's recommended that you leave this gas applied anywhere from 1.5 minutes to 2 minutes. So when you apply the zero gas, let it purge for 1.5 minutes to 2 minutes before you set your zero. When you go to your span gas, you're going to let it flow for 1.5 minutes to 2 minutes before you adjust your cal pot. Okay? So there's an algorithmic formula that you use to calculate your millivolt output depending on what gas you're using. In our example, and what you guys would probably use is, again, set up for 35% LEL. Okay? And 35% LEL represents 96 millivolts. There is a formula in the Xgard that basically takes your calibration gas, divides it by the range of the sensor, multiplies it by 40, and then adds 40 to it or something like that. So you use that algorithmic formula that's in there for you to calculate the millivolt output depending on what gas you're using. Make sense?
Yeah.
So if you're using, again in our case, 50% LEL pentane set for 35% LEL, you're going to set your output for 96 millivolts. At 96 millivolts, again, if you're reading not dead on 96, you get in that cal potentiometer and you adjust it clockwise to increase it, counterclockwise to decrease it. Once you get at 96 millivolts, you'll have someone verify that you're reading 35% LEL at the controller.
Okay.
And that is a full-blown calibration that you just performed. Any questions? All right, so that's calibration. Now, if you were just going to do bump gas response check, you would go to each one, you just take your span gas, you would apply it for, say, 15, 20 seconds, make sure that you have a gas response for each gel, and verify it in the Vortex. Mm-hmm. All right. Good? Any questions on calibration? Nope. All right. All right, so we kind of went over everything.